Yeah, this is 7.4, the last of our rules of exponents. This is division properties of exponents. Going back to something new, just the definition of what it means to be 4 to the 5th over 4 to the 3rd. Let me write that out. We've got 4 to the 5th would be 5 copies of 4 times 4 times 4 times 4 times 4. We have 4 times 4 times 4 representing 4 to the 3rd. There's a certain type of canceling that happens here. We have 4 divided by 4. That's canceling to equal 1. So each time I have a 4 over 4, it equals 1. And then I'm just counting how many 4s are left. You can see there are 2 4s left, so that'd be 4 squared. All of these 1s, you could think of them as a product. So it's like 4 squared times 1 times 1 times 1, and then on the bottom you have 1 times 1 times 1. Because that's the multiplicative identity, it's just going to be 4 squared. It's just 1 times anything is the anything, is what we mean by that. Go over to this other one. So notice first on the first one we had more 4s, actually 5 of them in the top and less in the bottom, and we end up with 4 to the 2nd. Here we have C times C times C times C, C times C times C times C times C times C times C. So there should be 1, 2, 3, 4, 5, 6, 7 C's. Each time we cancel a C, we do have a 1. And so you'll notice on this one there are 3 C's left on the bottom.
Students, please come to the counseling office. Brianna Munkers, Shane Pratt, and Gemma Meadows, please come to the counseling office. Thank you.
And so as we're looking at this, we really don't want to write down all the copies of the 4s or all the copies of the C's and be canceling in this way. You could see this would be problematic if you had very large whole numbers. Also, when we get into fractions or even negative numbers, we're going to have problems using this method. This method is kind of an arithmetic method. Something like this you've probably done in a pre-algebra or arithmetic class before Algebra 1. But what we notice here is that on this one, 5 and 3 has a difference of 2. On this one, notice that if I took C to the 4 minus 7, I would get C to the negative 3, and by our prior rule of exponents dealing with negative powers, we would write this as 1 over C to the 3rd. So what we notice is we don't need to write down the copies of x and cancel them. What we can do is just copy the base down when we're dividing and subtract the powers, and we've got our simplified version. Now if a negative number shows up like it did right here, you then have to apply another one of the properties to take care of that. So the rule here, this is our 5th and final rule of exponents, is if you're dividing powers with the same bases, subtract the exponent. So if you're dividing powers with the same bases, subtract the exponents. Now, some students like this idea that we saw up here and up here, and can apply this other option here. It's really more of an option if you're thinking in terms of arithmetic and not thinking a little more abstract and with the big picture of algebra. So, but this works. It helps in most cases. Here it says, ask yourself, where do I have more and how many more? So what I mean by that is up here we have 5 4s and 3 4s on the bottom. So we have more 4s on the top, and the number of 4s we have on the top more than on the bottom is 2 of them. So where do I have more? I have more 4s on the top. How many more? 2 more. Whereas on this one right here, I have more C's on the bottom. How many more? There are 3 of them. That would work here as well. You can see if I took this one, there are 12 X's on the top, 5 on the bottom, so we have 7 more X's on the top. And so it's another way to think about it, which works nicely as long as we have positive whole number powers. So that method is a little bit limited when we start thinking about, okay, now I have x to the 3/2 over x to the 1st. Well, if I were to think about how many more do I have on the top, well, I guess I could think in fractions. But if we think in terms of our rule that says, I don't care what type of number we have as our fraction, the rule says if you're dividing, as long as x is non-zero, we have the base to the power of 3 over 2 minus 1. We just subtract the powers. 3 over 2 is the same as 1.5, and so I have 1.5 minus 1 as my power. So my final answer is x to the 1/2. That's it. We just leave it like that. You should understand that x to the 1/2 power is the same as the square root of x. So in your homework, as a matter of fact, you'll get something like 9 to the 1/2 power in one of the problems when you simplify it. That's the same as square root of 9, or 3. So 1/2 of the power is the same as taking the square root. 1/3 power would be the third root. 1/4 power, the fourth root. You will need to know that anything to the 1/2 power is the same as the square root. Now, when you have more than one letter in the same problem, we're going to just do this process twice. Copy down the m to the 2 minus 5 power and n to the 4 minus 3 power. So I have m to the -3, n to the 1. And then I've got n over m to the third when I move that m down to the bottom. What you try, the now you tries, you might want to pause the video. I'm just going to write up the solutions here so you can check. Alright, so those are the solutions to the now you try problems. Hopefully you're able to get those. Alright, we talked about this actually earlier on. This came up earlier on before this lesson. So quick review here. Even if you have a quotient or you have a fraction here like we do, with parentheses around it, we've got to apply that third power to everything, top and bottom, in parentheses. So this would be x to the 9th. So we are multiplying 3 times 3, so x to the 9th over 5 to the 3rd. So it's x to the 9th over 125. And on this second one, we're applying the second power to the 2 to the a. So 2 times 3 would be 6. And to the b, so b to the 4th here. So this would simplify as 4 a to the 6th over b to the 4th. Go ahead and try the now you tries. Maybe pause it, try them, check your answers. So those are the answers for the now you try problems. So just remind you of one more thing here. When we have a negative power outside of parentheses, we're going to use the second rule of exponents that we learned, the a to the negative n equals 1 over a to the n. The idea that you can take the reciprocal of what's in parentheses and change the power to positive. So if you rewrite it using the reciprocal, then you can change this to a positive 2 power. Now, could you apply the negative 2 power to each of these separately? Sure, you could. And then in the next step, move any negative powers to the appropriate portion of the fraction to make it positive. But I think it's a good idea to take care of that negative power first and then apply it just as we did in the previous example. Here, this reciprocal would be y to the 4th would come to the top. This is a negative power here. Hopefully you see it in your packet. It's faint here. This would be a positive third power, and then we'd apply the third power to each and every letter and number, top and bottom. So it's y to the 3rd over 8, x to the 18th. So try the now you try. I'm going to go ahead and do it. Change that to a positive 2 power, so we have 5 squared, b squared, a squared, is 25, b squared over a squared. So be sure to summarize it. As a quick summary, we're just using the mathematical symbolism to show that our rule is take the base when you're dividing and subtract the powers. That might be a good summary. If you haven't summarized all 5 rules, you might want to add them all to this last page as we finish up the rules of exponents. All right, thanks.